Information gathering. So this is a slide on information gathering, which I would say is more applicable to stage 3, stage 4 LCA. Maybe if you come on at the tail end of stage 2, literally the last week or two, then you might have some of this information available. You might have a cost plan, which is a very useful source of LCA information. You might have a BIM model complete. You might have some drawings where you can manually measure up windows, floors, wall areas, understand what the specs are, and the overall quantities, 150 meters of piling from structural engineer drawings or from the cost plan, 5,000 meters squared of concrete slab from the cost plan or the BIM model. But that sort of level of information, yeah, really good, will give you an accurate LCA, but it's not available at stage 2, certainly not at early stage 2, which is ideally when we want to be running that first round of analysis. The BREEAM credits are very much focused towards trying to ingrain a bit of LCA thinking into the design team. And that's all about getting in there as early as possible, presenting some results, and then trying to refine your model, refine your assumptions, and look at recommendations in a bit more detail at latter stages. So at stage 2, early stage 2, which is ideally when we've come online, that's about the level of information that you might have. We're building 5,000 meters squared of office. We want to have a look at some LCA analysis. We've got this stage 2 requirement for BREEAM, so let's get stuck in as early as possible and see what we can get from an LCA model with that level of information. And we'll come later on at stage 4 and update it and build a more accurate, I guess, LCA of the project. But for the time being, all we know is that they're building 5,000 meters squared of office. It's probably going to be concrete for that size office, but it might be steel, it might be curtain walling, it might be brick facade. Lots of options still on the table, and we really want to get in there early and be running analysis on those options right from the outset. We come in at the end of stage 2, they've already decided, okay, we're going to build out steel, we're going to use curtain walling, we're going to do X, Y, and Z, and your LCA, stage 2 LCA, is almost redundant because those decisions have already been made, and you're now thinking more about stage 3, stage 4 decisions and the analysis on there, which is still useful. Don't get me wrong there, yeah, it's still useful to run an LCA later on at stage 2, but the idea with these credits is getting in as early as possible. That's the intention, to try and ingrain a bit of LCA thinking into the design from the outset. So that's all the information we have to go off, so that's all we can build our model off. And we have some quite well put together templates within eTool to do exactly this, and they will probably be plus or minus 10–20% of the final LCA results, but they're certainly accurate enough to start presenting good design options and running through recommendations with the design team. We always say it's better to be vaguely right than precisely wrong. Better to get some analysis done early, get something vaguely right in front of people, start chatting through, start the dialogue, get engagement from the architects and the structural engineers, rather than just ignore it until a later stage when you've got more precise information. So you're precisely wrong at the start, but you wait a while and then you get the information, but then the decisions have already been made anyway. So the process hasn't been as effective as it might be if you get stuck in as early as possible, get something vaguely right in front of people, and get the chat moving about different options. So without further ado, let's get stuck into a example model. So this is all the information that we have. Again, early stage 2, maybe right at the outset. Let me just check nobody's got any questions there. No, good. And I'm going to build a model. Here I am, eToolLCD.com. I'm going to go to new project. Organization, by the way, I'll just run through these very quickly. We can save this project to our company organization so that everybody in my company can view it and collaborate on it, share it, or I can have it in my own private account. LCI group, this is for BREEAM as well as for the design team, so I'm going BREEAM impact. LCI source for 2018, or for any job actually now, we should be using version 5, it's the most up-to-date data set. That's the background data for all the materials, etc. that are going into the building. This is the background data set that we're choosing, and version 5 is what we need for 2018. Project name, just going to call it 5,000 meters squared office. It's so early it doesn't even have a proper name. Early stage. Actually, no, I'll define that later on. Land area, just for the sake of this exercise, we'll call it 1,000 meters squared. It's about a 5-story office. I'll put our address here at the Brighton office. Actually, I'm at home at the moment, but yeah. Project manager, we're building this ourselves. LCA. This text feeds through to some of our automated reports. It can be quite useful to have a nice picture of the project if available, or some details about the design team, what they're hoping to get out of it. We want true zero carbon, we want supreme credits, we want to get circular economy principles in there, or look at resource efficiency, etc., etc. So, yeah, a bit of a description about the project on 5-story. I'll keep it pretty light for this. Here we have the lifecycle modules, and these will default for impact. The impact data set can't measure things like module D, which is our recycling credits, measured in module D under 15978. Doesn't measure waste processing and demolition and things like that, but generally it's pretty close to 15978, and it's by default, so we can't adjust anything there. In our other data sets, you can play around with these modules and indicators as well if you want to turn them on and off. I might think about doing an LCC at stage 2 as well, so turn this one on. Eco points, let's have put that on anyway as well, just in case we want to have a look at eco points. Then we have our grids. Yeah, it's UK grids by default. Water grid, we'll just use tap water for these. These other items, inlet water temperature, they come into play with some more complex energy templates that we won't deal with, or I rarely ever actually deal with them for UK jobs anyway. Financials, so if we're looking at LCC, then this is some of the inflation and discount rates that we want to apply to our cost data. So that's my project level. Within a project, we'll have structures. So we might have our first structure as early stage 2. analysis. We might have another structure later on, stage 3, stage 4, maybe do a final design. We might have a precinct or something where we have lots of different structures, an office, retail, the resi, etc. For this one, we'll just keep it's just fairly simple. It's a 5,000 meter squared office. We're getting involved in stage 2. It's the whole building. Here's our address. Early stage 2. Construction scope, so it's a good idea to have a rough idea of what you're planning on including within your model. We're going to include substructure, superstructure. We're not going to include decorations on the roof. It's out of scope. We can update this later on. Certainly want to update it when we get to the final LCA. We're probably today not going to look too much at services and fittings. We might include these later on. Energy and water scope, we won't look at energy today. We're just purely thinking about LCA, embodied carbon, the materials, and the broom side of things. Best practice LCA would be to include energy, and if we're doing an LCC, then we would add in some of our energy templates to this. So again, you know, I might come back later and update that if we decide that we want to turn the life cycle environmental study into a life cycle cost study. Base design. And I'm going to call it substructure and superstructure. And you'll see why that I've done that in a minute. It helps with the BREEAM reporting. We've got 5 levels. Don't need to worry too much about energy monitoring adjustment factor purpose. It's a base design, or maybe, yeah, we'll call it base design. It's help with our reporting later on. These factors all contribute to an algorithm that we have that calculates the life expectancy of the building, and we'll be updating that manually because for BREEAM we need to be looking at a 60-year life expectancy. Primary function, we're looking at office, probably a multi-tenant office building. Office. We can look at breakdown results in the model of different functions of a building. You might have a car park, a retail, a common area, a lobby, and you want to look at the results separately for that. So going into a more detailed LCA, generally I just have one function, certainly at this stage. And make sure these items are updated so we know that it's 5,000 odd meters squared. It's very little unenclosed area, net lettable area, probably in the region of 4,000 or something, 3,500. Occupants, shall we say 400 for now? Tenancies, maybe 1 each floor. We can break down the impacts in terms of kilograms per occupant, per tenancy, per meter squared, and that's where this information feeds through. For BREEAM, we need to do kilograms per meter squared of gross floor area, so we need to make sure that that's updated there. If we do want to look at kilograms per occupant, then make sure that these are updated. I always think it's interesting to understand from a personal point of view, okay, it's going to cost the planet this amount of carbon for me to use this office. Let's see, that's updated there. And this is our model. So some of you online are pretty familiar with how to build an LCA. Some of you aren't, so just very quickly show you the different variables. So at its most basic level, an LCA is built up of different material items, and here's all the different variables that feed into the environmental impact and the cost of installing a material. So we have maybe some clay roof tiles. Here we saw all of those items populated by default. So the software has default figures for construction waste, for life expectancy, for transport distance, sheet thickness. So we can update all of these manually. Maybe the client has a specific target for zero waste. Maybe the manufacturer has longer life expectancy than this for, it depends, but generally we'll leave it default, and certainly for stage 2 I wouldn't be going into that level of detail just yet. So we have our roof tiles, and it's 1,000 meters squared. Now that's just the roof tiles. Somebody has to come and install them. They have to go on to some sort of structure within that roof. There will also be insulation, there'll be finishes, there'll be maintenance, there'll be in this case clay, probably some cement, water in between the tiles, all sorts. And what we've done at eTool is built up, and the eTool community actually as well, has built up these template libraries of construction makeups. So if I'm looking for a whole roof system, I search for a whole roof system, and I see lots of different options here for roofs, metal deck, timber frames, insulation, including finishes, membranes, ceiling, paint, bitumen, etc., etc. It's looking for one with clay tiles in it. This one's got concrete tiles, so let's just run with that for now. And it's 1,000 meters squared. And we see there that now we've included the membrane, we've included the insulation, we've included the slate tiles in this roof. We also have people to come and install it. The people impacts are pretty small in terms of CO2. It's just somebody with a excuse me, just somebody with a drill really putting this thing together. But for other templates, it might be more complex. And certainly when we look at cost, and quite easily flick using this templates, flick between an LCA and an LCC. We see the costs are actually quite high for this 466 grand to install this roof and redo it actually over the life cycle. Whereas the actual materials are 244. So yeah, people fairly negligible for an LCA, but very important to include for an LCC. Just reminded me there actually whilst I was installing that we have a life expectancy here of 155 years. I just noticed that that roof had quite high recurring impacts. So that's this part here means the roof is being replaced. Parts of the roof are being replaced fairly regularly. But our life expectancy is 155 years of this building. We need to update that to 60, which is what's required for BREEAM. Nope. Bear with me a sec. Now we see the recurring impacts have dropped down significantly. It's only maybe the membrane or something that might get replaced in there within that 60-year time frame. If the building was lasting 155 years, then yeah, the roof will get replaced a lot more often. So yeah, that's a very quick overview of building a model normally. We have all these templates, and they're filled with lots of different materials that go into the model. But at this stage, we don't even know that there's a roof with concrete tiles. We could build, add the 20 odd templates for the floor, the walls, the windows, etc., and try and guesstimate the areas. But we've got a template that already does that for you and makes some business as usual baseline assumptions, which is basically all we know at this stage. All we know is that they're building 5,000 meters squared of office. So we have what's called target setting templates. In the past, we had target setting exercises for planning approvals, actually, mainly in Australia, although I know some users have done LCA for the purposes of planning over here in the UK as well. But yeah, we built these whole building templates to put in front of the design team and start to try and run analysis. So we have whole buildings that include services and fit out of a retail, of an office, of a hotel there. We have whole building templates that just look at a kind of steel structure, composite deck, fit out whole building templates again there. That one's a whole building template for a concrete structure. What I'm going to do is add this one in, which is just the sub and superstructure, which is all that's required for BREEAM 2018. If I was doing an LCC, I'd probably add one of these more detailed ones that includes services, fit out, etc. Yeah, for the purpose of this exercise today, we will just look at the sub and structure. I think there's some landscaping in there as well. So it's asking me for a gross internal area for this project, 5,000 meters squared. I see a question has popped up. I'll come back to that question later, Christina, if that's okay. Please remind me if I don't. So I've added this 5,000 meters squared of office, and within that, we can see we've got some stuff in there for equipment, for people, substructure, superstructure, a bit of finishes, and some external work, some landscaping there. We can drill down into the individual templates that make up this this building, and we see we've got some piling in there. The assumption is 350 mil diameter, and there's about 64 meters of piling on average for a building this size. When you get to the latter stages of the design, you'll be able to update this or reload it. Maybe they've managed to reduce piling completely and just gone for the strip foundations. You can run that analysis of the difference that makes between these two systems. We've got some internal walls, core walls there. We've got a staircase. We've got some doors, door framing. We've got, assuming, some concrete paving slabs and the landscaping. Concrete roof, concrete upper floor structure, internal walls, curtain walling system externally, insulated spandrel, some more internal walls there, some concrete framing, quite significant, landscaping, a bit of scaffolding and excavation and things. So that's basically our substructure, our superstructure, and our hard landscaping, which is what's required for the BREEAM analysis. And it's also the big ticket items that we want to be thinking about at this sort of stage. You know, what's the difference between a concrete slab and a composite metal deck, a steel frame or concrete columns. Anything that we can do with the foundations to improve the efficiency there, or maybe alternatives in terms of the material choice, looking at fly ash, ground burst, flying slag. We can see already where I want to focus my attention. It's this upper floor slab. Is there any efficiencies that can be gained there, or alternative materials? external wall, curtain walling system. How does that compare to another system? And the framing there. So what I'm going to do is make a copy of this. This model. I'm going to call it option 1. And I'm going to run on superstructure. And I'll put some fly ash in the slab. This is another scenario that we're running. And I'm going to use the recommendations feature here. And I think we have a fly ash, different fly ash blends. So maybe we want to start with a 30% blend and work our way up. See if we can push them further, or hit them with a 50% blend to start with, and let them, the design team, pull us back to 40 or 30%. Yeah, different approach depending on what your feeling is from the client. One with this one for the time being. We do have others actually that we can look at, 40%, 60%. I was at a conference yesterday and somebody had got a 70%, this was blast furnace slag rather than fly ash, content concrete, and they were also actually offsetting the 30% Portland cement by purchasing offsets. So they were claiming a zero carbon concrete there, which was yeah, very interesting. Great that they've got that higher percentage in terms of concrete with the same structural and setting times, etc., as normal concrete. Sounded more pricey, 5–10% more expensive, but an interesting one nonetheless. Okay, so I'm recording this recommendation. I want to make the change. And what I'm going to do, there's lots of different ways we can make updates to the model or make these kind of changes. In bulk swap, we can select different materials and update their quantities or their actual material, swap plasterboard for timber, swap out the paint, make bulk changes to any one of those variables that you saw when we looked at an individual material. Bulk change to recycled content, to quantity, to waste factors, transport losses, transport distances, etc. In this case, what I'm going to do is just swap out a whole template for a fly ash template. So I'm going to look at how much concrete I've got. And some of these templates are nested within nested within nested. They can go quite deep. This one is upper floor structure, and nested within that is some concrete, 1,500 meter cubed of concrete for that particular area of upper floor structure, 300 mil. So I'm going to delete that one after copying the quantity. And I'm going to add in fly ash. We have lots of different fly ash templates here. Here's a 30% one. Here's a 40% one. I think we do have 50% as well. And I'm going to upload that. Save it. And go stop recording there. And that's one of my options, basically, option one. What are we doing for time? Should I do another one, or do people kind of get the process there? It's, yeah, make a copy of your base design, figure out what you're going to change, make the change, and we can save it here, and that's the impact that that's had in terms of CO2. Yeah, that's yeah. Does anyone have any questions there? Actually, before I jump into, I might as well in the last 20 minutes just have a look at the reporting if you haven't seen it already. But yeah, in terms of building the model and running those options, it's got some questions. So Christina asked earlier, the costs that we're looking at, are they UK market? Yes, the cost database was, I built it based on project experience, based on manufacturer quotes, based on SPONs, which I also sort of cross-referenced that data with SPONs to make sure there was some alignment there. So yeah, it's the UK cost data set. What I would normally do with an LCC, yeah, use this approach if you're coming on early, but if you're coming on a bit later, you'll have a cost plan available, and you can import that cost plan, and the cost plan will also scale the costs of our templates to match what the cost plan's saying. So your upper floor template in this case will have the same cost as what's stated in the cost plan, and everything will scale up accordingly. Normally it'll come in fairly close anyway, but obviously every project's different, and the cost plan, the QS has assessed it in more detail than our templates have here. Where was the next question? Percentage improvement. Yeah, good point. So what was that in percentage terms? I think we can present that, but we need to select what we're comparing it to. So we'll select the base design as our base design. We should see a percentage saving there. I wonder if it's fairly minimal, so it's not coming up as a percent. Let me just double check whether this makes a difference. If I call it improved. Bear with me a sec, there's quite a few of us online now, so it's just catching up. Still zero, I have to look into that for you. It should certainly normally come up with the percentage improvement as well. I haven't used that feature for a little while, so just trying to remember how it works. Base design there makes sense. I would expect a percentage improvement. We've got 266,000 kilograms over the lifetime, and as a percentage of of 1 million. It's, well, yeah, it's almost too much. It might be that it's just too little to come in there. I'll double check that and get back to you. Yeah, if you are running this and you would like to see that, then we'll certainly make sure it's fully working. Yeah, I'd need to dig in for 10 minutes and just double check where that result should be feeding through from. Actually, I think we might even have a video somewhere that looks at that in more detail. Any other questions in terms of, yeah, that whole building template, putting it together, chucking it in? We're doing an early stage model, and then we're making some copies and showing some reductions and where we could target our big ticket items to try and think about reductions. And yeah, they'll be looking at things like steel frame. Maybe you can look at timber frame even. Maybe you can look at yeah, any kind of fly